In this set of notes, we're going to deal with rational exponents, okay? If you'll think back to our previous set of notes, the last property that we didn't use was how you deal with rational exponents, all right? So I've kind of put those here. So if you got a rational or a fractional exponent, a to the m over n power, okay, remember the denominator goes with the root here. The numerator stays with this base a, okay? You can also write it as, again, the denominator with the root and that whole expression being to the m power. Either way you write these is going to be okay, all right? I think primarily we're going to deal with doing this way, but in some cases it'll be better to use this one, okay? If the root is even, remember that a has to be greater than or equal to 0. We can't take the even root of a negative number, okay? That's going to be undefined. We'll talk about complex numbers later on in the class, but for now we're going to say that a has to have a domain non-negative, okay? Bigger than 0 or equal to 0, just not negative, okay? With this definition, it can be proved that the laws of exponents also hold for rational exponents, okay? So we're going to have to continue using the rules that we learned with our laws of exponents, okay? We learned those earlier in this course. We're also going to use the rules that we learned about simplifying radicals in the previous set of notes, okay? So in this video, we're just going to do problems 1 through 4. I'm going to break these up to keep the videos kind of short here, okay? So 4 to the 1/2. All right, remember the denominator is going to be the root, so this is going to be the square root of 4 to the first power, okay? I went ahead and put the 1 up there as an exponent, but you guys know that's not necessary. It could just be the square root of 4, and you guys know the square root of 4 is 2, okay? So 4 to the 1/2 power just means the square root of 4, which is 2, okay? Pretty easy one there. Number 2, 8 to the 2/3, okay? Remember the 3, the denominator here is the root, so this is going to be a cube root problem. So the cube root of 8 to the 2nd power, okay? Cube root of 8 squared. Now again, this is the type of problem where it's better, in my opinion, to write it like this. If you were to write it like this, it would take a little bit longer to get to the answer, but you would still get there, okay? 8 squared we know is 64, cube root of 64, and 64 happens to be a perfect cube, okay? 4 times 4 times 4 is 64, okay? So the cube root of 64 is going to be 4, all right? You can use a calculator, 8 to the 2/3 power, and you'll get 4, but we still need to know how to rewrite fractional exponents using these laws of exponents, okay? Number 3, we've got a negative power here, so we want to move that through the fraction to the bottom half, so it's going to be 1 over 125 to the 1/3 power, okay? So it's going to be 1 over the cube root of 125, and hopefully we know the cube root of 125 is 5, okay? So 5 times 5 times 5 is 125, so this answer is going to be 1/5, all right? And number 4, later on in these notes, we're going to show you how to rationalize a denominator that looks like this, okay? But for now, we're just going to play around with the rational exponents and make sure we know how to do that. So we can rewrite the cube root of x to the 4th as x to the 4/3, so 1 over x to the 4/3. And just to show you, that you can move that through the fraction, and we get x to the negative 4/3. Now, here it says leave any fractional exponents, so we're not going to simplify this. We would need to, okay? Later on, I'll show you how to do that. You don't want to have negative powers. You don't want to have fractional exponents in your denominator, okay? So I'm going to show you how to simplify this. But for now, just to kind of understand how this process works, we're going to go ahead and leave it like this, okay? So that's part 1. Let's move on to part 2, and we'll do the rest of this page.